Well, we look at F.J. Pettijohn's quote. Now, when he said, the cause of such laminations are variations in the rate of supply or deposition of the different materials. Boy, I'm glad I didn't take geology. All this vocabulary. These variations might result from changes in the quantity of silt, clay, calcium carbonate, or organic matter in the seawater, or to changes in the rate of accumulation of these materials. So how come these evolutionists and geologists, evolutionists, are so sure of everything? Such variations have been attributed to the fortuitous shift in the depositing currents, to climatic causes, especially cyclical changes related to diurnal or annual rhythms, wow, and also to aperiodic storms, however you want to pronounce that, or floods. Oh, I like the last one, floods. Kind of puts it all together because it brings it all together, right? Worldwide flood especially. Now, neither can more extensive varve deposits such as at Green River, which consist of great thicknesses of thinly laminated shales, be interpreted over a long period of time. The most thorough study of rocks thought to be varved are the Green River shales, Wyoming and Colorado. Huge area. The shales are very thinly layered, and each layer consists of two laminae, one of which contains considerably more carbonaceous material and matter than the other. The paired laminae are interpreted as representing the sediment laid down during 1 year, in short, a varve. An interpretation which is, varve is evidently a year, an interpretation which is strengthened by the fact that the varves, which are considered a year's worth of deposit, fluctuate in thickness in a cycle corresponding to the sunspot cycle. The varves average less than 1/2000th of a foot in thickness. How do you measure it that way then? Microscope, huh? And as the Green River shales are 2,600 feet thick, and just 1/2000th of a foot, you're going to measure it? Wow. That's a little arrogant there. The time represented by the accumulation is almost 6 million years. That's just fiction. Who wrote this story? Yeah, it's a story. It's not real life. Adolph Knopf, Time and History, Earth History. However, in the above study itself, only two very inadequate reasons are given for believing the layers are to be annual. One is a calculation purporting to show that the amount of sediment in the formation is of the same order of magnitude as the probable amount of erosion from the ancient drainage basin contributing to the lakes whose beds are supposed to form these shales. But obviously anything as so hypothetical as a calculation involving a watershed of entirely speculative extent, slope, character, erosibility, and drainage characteristics, all taken as the basis for estimation of average rates of erosion, a type of calculation which almost everyone now admits to be nothing but rank guesswork. Yeah, I didn't have to be a scientist to figure that out. Can hardly warrant so far reaching a conclusion as that the accumulation of the formation required about 6 million years. Wow. So, in the above study itself, only two inadequate reasons are given for believing the layers to be annual. Sorry for the interruption. One is a calculation purporting to show that the amount of sediment in the formation is of the same order of magnitude as the probable amount of erosion from the ancient drainage basin contributing to the lakes whose beds are supposed to form these shales. Lots of supposing. But obviously anything is hypothetical. So it's hypothetical as a calculation involving a watershed of entirely speculative extent. Huge. Beyond any normal idea. Slope, speculative extent, slope, character, erosibility, drainage characteristics, all taken as the basis for estimation of hard average rates of erosion. A type of calculation which almost everyone now admits to be nothing but rank guesswork can hardly warrant so far-reaching a conclusion as that the accumulation of the formation required about 6 million years. Now, the other reason for concluding the laminations to be annual varves was their similarity of appearance to be the varved clays of the so-called Pleistocene and the fictional and to a lesser extent banded sediments found in certain modern lakes. This is the old principle of uniformity again, what we see over here, and then they lie about it because nothing is uniform. A lot of different minute changes here and there, and they add up to so many differences that could have resulted. The resemblance, however, is largely superficial. The so-called Pleistocene varves are much thicker than the Green River laminations, which average less than 6/1000ths of an inch in thickness and reflect glacial melt water deposition, whereas the Green River shales are denoted mainly by a cyclic repetition of organic and inorganic matter. Apples and oranges again. The inorganic layers of the Green River shales are quite rich with petroleum deposits, unlike the thicker Pleistocene lake deposits. And nothing similar enough to compare. With respect to the Green River shales in particular, several factors make it highly doubtful that they could possibly represent annual varved layers. For one thing, they are entirely too thin and uniform and extend over too wide an area to have been deposited in a normal lake bed. No matter how calm a lake may be ordinarily, occasional storms stir up the bottom sediments, and occasional river floods dump into the lake large quantities of sediment, which would then settle out on the lake bottom in an essentially graded series. To imagine that such an extensive lake, fed as it must have been by many rivers, could continue so impossibly quiet and inactive and undisturbed for 6 million years is somewhat ridiculous. They just cast off with a little phrase, uniformitarianism. The Green River shales are also rich in fossils, a fact which is hard to reconcile with the supposed quiet manner of its formation. How do all those fossils die or get dispensed with? Miller observed, the Green River formation is a freshwater lake deposit composed largely of evenly stratified soft shales as much as 2,000 feet thick. Many fossils, including fishes, insects, and plants, occur in it. Something had to happen. W.J. Miller, An Introduction to Historical Geology. Here's those college textbooks again. How does one explain, for example, a dead fish lying on the bed of a lake for about 200 years while the slowly accumulating sediments gradually cover it and then fossilize it? Now we have something concrete, a fish. We know how the width, length, and depth and weight of it. Other significant features include the extensive deposits of volcanic ash mingled with the shale and the almost complete absence of any graded bedding in the oil-rich shales, such as would be normally encountered in any lake bottom sediment. Not the world's best typist. Also, there is evidence of brecciated conditions in many parts of the formation. All of these features seem difficult to harmonize with the postulated character of the beds. The absence of graded bedding in the shales is significant. If the individual layers have been deposited by simply settling to the bottom of a quiescent lake, it seems, in all that time, millions of years, it seems certain that each layer would be marked by a gradual decrease in particle size with increasing elevation. The laminations are marked strictly by thin layers of black, organic, rich matter, and the location and frequency of these seem quite irregular. The only certain conclusion from the very nature of the deposits would seem to be that they could not have been formed as cyclic varves as claimed. A possible plausible explanation might be in terms of a vast sedimentary basin formed by the gradual uplift of the land surrounding it in the later stages of the deluge period. A complex of shallow turbidity currents carrying the still soft surface sediments and organic slime from the surface of the rising lands would then enter the basin, mingle, and deposit their loads. Slight changes in velocities or compositions of the turbidity currents would account for much of the laminated appearance of the central deposits. Although it is possible that the accumulation of the organic matter into a succession of thin seams was also partly caused by later physico-chemical factors affecting the sedimentary mass. The general appearance of the Green River Formation as a whole seems consistent with this sort of concept. Banded deposits need to not be explained as annual deposits at all, or even chronologically cyclic deposits in many cases. Various types of chemical reactions are known to be capable of producing this type of phenomenon. So we can't be out there, we can't see how over 6 million years, each little thing and each little difference or each little similarity might be cause of something quite different than the same old thing. Uniformitarianism. A third school of thought is that the bands represent a cyclic precipitation, or so-called diffusion banding, or lysogang phenomena. Reacting solutions of chemicals do this if oversaturation is required for the reaction to start. The reaction starts, uses up all the chemicals in the vicinity, and makes a band. Then it won't start again until the same point of oversaturation is again reached farther down or farther out. All these possibilities. And when you're not there, you can't make up a formula. R.L. Handy, Screenings from the Soil Research Lab. Now we get to oil deposits. Same kind of conditions. Presumptions, uniformitarianism. But too many things could happen over such a long period of time. Uniformitarian geology is frequently defended on the ground that it has worked so well in leading to the discovery of economically important deposits of petroleum and metals. So it's when you find the oil, okay, it is maintained that it must be basically correct, or else it could not have served so well as a guiding philosophy in economic geology, or just oil greed. But two replies can quickly be given to this sort of statement. In the first place, it has apparently not worked very well at all, as the discovery of valuable deposits of any kind is hardly on anything approaching a fully scientific basis as yet, and still not. In the second place, such techniques as have actually been found helpful in exploration do not really depend on the historical aspects of geology at all, but only on recognition of the structural and sedimentary markers that experience has shown are associated with such deposits. As a matter of fact, I can add a point. When I talked to the scientists and actually a geologist involved with discovering oil on this matter, he said, we don't go by all that textbook geology stuff. We just look exactly for the sedimentary markers that experience has shown are associated with such oil deposits. He didn't want to go over it. He said, well, it's so many years ago. I went to college and the guy passed the geology course, but there are techniques to look at. It's really particular pointers. You look at certain markers, and then you keep looking in that particular area instead of the ones that don't have markers. As a matter of fact, oil discovery is still not very efficient scientifically. The following comment points up a few of the pertinent statistics, coming as it does from one of the country's leading petroleum geologists. Oil is getting harder to find. The high risks inherent in the research for oil are unusual in the business world. Statistics show that only one wildcat well in 9 discovers oil or gas. Only 1 in 44 proves to be a profitable venture, and only 1 in 427 discovers a field of 25 million barrels. And only 1 in 991 finds a real payoff, a major pool with 50 million or more barrels. R.D. Sloan, The Future of the Exploration Geologists. So much for the textbooks. You're not going to become an oil magnate by following that. Consideration of the biblical point of view of geology could hardly do worse in finding oil than the track record of the evolution-minded geologists. They have to be oil finding, you looking for the markers. As yet, in fact, uniformitarian geology has not been able to develop even a generally accepted theory as to the origin of oil or its basic source material. So how are you going to find the actual hidden oil field that might be profitable? While agreement is nearly complete on the organic source of petroleum, there are wide differences of opinion on the process by which it was formed and on the nature of the organic matter from which it